Good evening. Today is Tuesday, November the 17th. Today in geometry, we looked at something called the isosceles theorem, and I will draw you a picture here and show you what the isosceles theorem is all about. So we'll share the screen and go there. Okay, with the isosceles theorem, if we first draw ourselves an isosceles triangle, so we draw ourselves an isosceles triangle here. And remember, an isosceles triangle has two sides equal. So we will assume if this is triangle, we'll call this angle A, and this angle B, and this angle C up top. And the isosceles triangle has two sides congruent, so we'll let this side and this side be the congruent side. Now, what we can do here to show the isosceles theorem, if we draw or construct the bisector of angle ACB. So we'll draw this segment that goes right down through here, and we'll call this point at the bottom here, we'll call this point D. So we'll say that CD bisects ACB, so that means that this angle here and this angle here are congruent. And then what we can do is we can prove that triangle ACD, so there's triangle ACD, is congruent to triangle BCD. So here's triangle BCD. And the congruency is by side angle side, because we have AC congruent to BC. We have angle ACD congruent to BCD. And then we have CD equal to or congruent to itself because it's reflexive. Now, here's the interesting thing that we haven't talked about before. When we're looking at two pair of triangles like this, there are 6 pairs of things. We have 3 pairs of angles, A and B, ACD and BCD, and then ADC and BDC. And we have 3 pairs of sides. Now, we have used 3 of those 6 pieces of information, 2 pairs of sides and 1 angle, 1 pair of angles, to prove the triangle's congruent. So what we're left with is, are 2 more angles, which is this angle A and angle B, angle ADC and BDC, and then side AD and BD. So what we can say here, we can say that angle A, now that we have the congruency established, we can say that angle A is congruent to angle B, and this is because of what we call corresponding parts of CP, corresponding parts of congruent triangles are congruent. Okay, this is, if you look back a couple of sections in your book, this is an abbreviation for corresponding parts of congruent triangles are congruent. I can say the same thing. I can use the same reasoning to say that section AD, or segment AD, is congruent to segment BD, because once again they are corresponding parts of congruent triangles, and they're equal. And then the final pair that I can use here is angle ADC, angle ADC is congruent to triangle, or angle rather, angle BDC, and it's the same reason. Corresponding parts of congruent triangles are congruent. Now here's the thing that the isosceles theorem said. And you'll notice here, if we have an isosceles triangle, if the sides are congruent, then the opposite angles are congruent. So if we look here and see, here's the side right here. This is side AC. The angle opposite AC is angle B back over here. And then here's side BC. And the angle opposite side BC is angle A over here. So what the isosceles theorem says, if I know AC and BC are congruent, then I know angle A is congruent to angle B. And the converse of the isosceles theorem says, if I know angle A is congruent to angle B, then I can say that side AC and side BC are congruent. So that's the isosceles theorem, and that's the main thing that we got out of today's lesson. If you'll notice, if I have an equilateral triangle is a isosceles triangle with all three sides equal. So the same thing applies to the equilateral triangle, and the equilateral theorem says an equilateral triangle is only equilateral if and only if it is also equiangular. So if you have an equilateral triangle, you know that all three angles are 60 degrees. So let's look at a situation here. So if we'll erase what we've got here, if you need to pause for a second and look at what we did, that's great. Otherwise, we're going to erase, and I'm just going to show you kind of a sample problem here, the type of problem that you can get with this isosceles theorem. Okay. All right, so the isosceles theorem, basically, if you have, I'm going to go back to black here so we can do this. Let's see something line with, let's do this right here. I've been working that line. Okay, so now we're just going to draw a triangle. So we just draw well, that one's kind of small. You can't see that one. Okay, here, let's do this. Okay, good. So we'll draw ourselves a triangle here. There's that side. And then we come across like this. And then we come down like this. Now, so this is triangle, we'll say this is triangle ABC. And if I tell you triangle ABC is isosceles, okay, that means that this side and this side are congruent. So if I come in here and tell you that this is 12, and you want to know this is y, okay, and then I can come down here and say that this right here is, let's say, 30. Degrees, and this over here is 4x minus 6. Now, so what I have to do, I have to solve for x and y, but remember what the isosceles theorem says. It says that the two sides are equal, so I know y is automatically equal to 12. But the isosceles theorem says that if two sides are equal, the opposite angles are equal, so the angle opposite this side is B, and the angle opposite this side is A, so I know that A and B are equal, so I could say 30 equals 4x minus 6. And I can add 6, and I get 36. And I divide by 4, so I get x equals 9. Now I can also do, so it's not 9 degrees. That's, I would want to do that. X is equal to 9, okay? Now, if you look, if I know the way the isosceles triangle works here, if this is 30, that means this is 30. So these two add to 60. So that means this top angle up here would be 120 degrees, because the three angles in the triangle have to add up to 180. Okay, so once again, I will go ahead and stop sharing here. Look at your homework. If you have questions, send me an email and I will get back to you. If you look at your schedule, the way it's going to work out, we will take the test on this chapter when we come back from Thanksgiving. So this week, tomorrow and Thursday, we have the next two sections, so you can look at those, and I will be sending you a video each night. Friday, we're going to do what we call plain and simple, which is just some classroom review work. So what you can do is start looking at the chapter review at the end of the chapter and prepare for the test when we come back from Thanksgiving. So I will see you tomorrow evening.